All right, so here we are with part 2. We left off with the distance formula in part 1. So here we're going to switch over to angles. All right, so take notes. This is 1.2 part 2. Angles and standard position. Okay, so when an angle is in standard position, so first of all, the initial side has to be along the positive x-axis. Okay, so let's write that down. Initial side is along positive x-axis. Okay, and the vertex is at the origin. Okay, so if you have this, your coordinate plane, and I'm going to draw an angle in the coordinate plane, then according to, let me go with this and something bigger. Okay, so according to this, the initial side needs to be along the positive x-axis, so that would have to be like here. And the vertex has to be at the origin. Okay, so this would be an example of an angle that's in standard position. Okay. All right. We have some other things about this. Okay, so we have these different quadrants. So depending on where that terminal side lands, then we say that, oh, okay, well, theta lies in quadrant 1, theta lies in quadrant 2, or 3, or 4. So let me show you what that looks like. Okay, so let me draw the 4 scenarios. 1, 2, 3, and 4. Okay, and if let me use this one. Okay, so if I have an angle, the terminal side there, well, this one will have terminal side there, and this one will have terminal side in quadrant 3, and this one will have terminal side in quadrant 4. Okay, so then what happens is we say that theta lies in that particular quadrant. So here we would say theta, ooh, that's too thick. Okay, hold on a second. Theta lies in quadrant 1. Here we say theta lies in quadrant 2. And here we say theta lies in quadrant 3. And here we say theta lies in quadrant 4. Okay? Now, if you notice, all of these examples have the terminal side of the angle landing in one of those 4 quadrants. So the question is, okay, well, what if the terminal side of the angle doesn't land in any particular quadrant, but it actually lands on one of the axes? Okay, so none of these land on the axes, but what if it does? Then what happens? What quadrant is it in? It's not in any particular quadrant. What happens is we call those quadrantal angles. Okay? All right, so quadrantal angles, the terminal side So terminal side lies along an axis. Okay, so let's draw the four scenarios. There's 1, 2, 3, and 4. Okay, so we might have that, okay, so the initial side is here, but then so is the terminal side. Okay, so I'm just going to do that to show that there are two sides of the angle there. Okay, we could have that. We could have this case. See how they're all landing on one of the axes? We could have this initial, and then here the terminal side. Could have this here the initial, and then this here the terminal. Okay? So what happens is, these are our quadrantal angles. And let me go back. So here, this would be 0 degrees. Here, this would be 90 degrees. Here, this is 180 degrees. This one here is 270 degrees. And if we go, well, and then of course this is if we're measuring in the positive direction, right? Okay. And then if we go full circle, then we're actually back here again, right? 360 degrees looks the same as 0 degrees, which I'm going to go into right now. Okay, so these are our quadrantal angles. Now we're going to take a look at coterminal angles. Coterminal angles. All right, so coterminal angles are two angles in standard position. Two angles in standard position with the same terminal side. So if you look above, 0 and 360 have the same terminal side. Okay, so 0 and 360 would be considered coterminal. Okay, and so we see here they differ. They differ by 360 degrees. Okay, let's take a look. So other than this 0 and 360 example, let's take a look at another example. Okay, so let's suppose that we have this here. Suppose we have 60 degrees. Okay, so let's go ahead and draw 60 degrees. All right, let me use my purple again. All right, so suppose that I have 60 degrees, which is roughly here. Okay, and this is 60. Okay. Well, what happens is I could look at this as 60 degrees, right? And that's if I'm measuring it this way, right? But another way to look at this is, oh, well, I've gone beyond 360. I've gone 60 degrees beyond a full circle, right? So I could look at this as, oh, okay, 60 degrees beyond a full circle, which is 420 degrees. Or I could say, oh, well, I could look at it in the negative direction, in which case I'm 60 degrees short of negative 360. Okay, so that would be negative 300 degrees. So 60 degrees here could be looked at these other two ways. 60 degrees could be the same as 420 degrees, right? Or it could be looked at as negative 300 degrees, right? Because if I do negative 300, I would go this direction, negative 180, negative 270, and not quite negative 360, 60 short. So this would be negative 300. Same thing with 420. I could go full circle, 360 degrees, and keep going 60 degrees more. So 360 plus 60 more would give me 420 degrees. Okay, so that's what we mean by coterminal. So here we could see that I could take my 60 degrees, add 360 to it, and that's how I would get my 420. Okay, or I could do my 60 degrees, subtract 360, and then that's how I would get my negative 300. In either case, if you just keep adding 360 degrees, then you will get a new angle that is coterminal. Same thing if you subtract 360 degrees. If you keep subtracting 360 degrees, you will get a new coterminal angle. Okay? So coterminal just means that they end in the same place. Their terminal side is right here. Okay? All right. So let's do this. Let's go ahead and draw negative 90 degrees in standard position. And then we're going to go ahead and find two positive angles and two negative angles that are coterminal with negative 90. Okay? So again, the way you do this is you just either keep adding 360 or keep subtracting 360. All right, so let's start with the positive. And we need two of each. Okay, so we have negative 90, right? So if I want to find a coterminal, then I add 360. Okay? So if I add 360, I get 270. So there's one answer. Okay? If I want to find another one, then I can add 360 to that. Okay? So I can add 360 two times. Okay? If I add negative 90 plus two 360s, then I get 630. Okay? So there are my two positive angles. If I wanted a third one, then I could do negative 90 degrees plus 3 times 360, right? And whatever I get there. Okay, if I wanted a fourth one, then I could do negative 90 plus 4 times 360. Okay, and then same thing with negative. Okay, so negative 90. So I'm going to go ahead and subtract 360. And here I get negative 450 degrees. I want two negative angles, so I'm going to do negative 90 degrees minus, now I'm going to do two of these 360. And here I get negative 810 degrees. Okay, so there are my two positive and my two negative angles. If you wanted a third one, you could do negative 90 minus 3 times 360. Do you see the pattern here? Okay. All right. Okay, so here are our two positive answers, and here are our two negative answers. Okay, so in general, if you're given an angle, any angle, theta, then all angles, coterminal with theta, can be expressed as theta, whatever angle you have, plus any multiple of 360 degrees. Okay? That's a K, if you're wondering what this was. Okay. That's a K. So where K is an integer. An integer is like 0, 1, 2, 3, 4, 5, negative 1, negative 2. Okay? All right, so that is it. If you have any questions about finding coterminal angles, make sure you email me or text message me. I will see you next time.